Welcome to our special report, 100 years after Alfred Wegener's The Origin of Continent and Oceans was published.
Alfred Wegener was born on the 1st November 1880 in Berlin and died on his fourth expedition to Greenland in 1930. He attended the University of Berlin, where he completed his doctorate in 1904. Wegener began his academic career at the University of Marburg in 1908, where he taught astronomy and meteorology. It was in 1911 when Wegener published his first books, The Thermodynamics of the Atmosphere. There was a break in his academic work as he fought in World War I for Germany. After he became the head of the Department of Theoretical Meteorology at the German Marine Observatory in Hamburg and collaborated with Köppen. In 1915 he published his most famous work, The Origin of Continents and Oceans.
Factors that influenced the theory included scientific interests such as his book The Origin of Continents and Oceans was influenced by his visit to Greenland, where he was inspired by the motion of floating ice to conceive the idea of drifting continents. He was impressed with results of a surveying expedition in 1906 which suggested Greenland had moved westward several hundred metres since a previous survey in 1870. However, it was wrong due to faulty results, and the failure of the test ultimately destroyed his credibility. The theory has also been influenced by other people, and there has been controversy over who was first to suggest the movement of continents. Francis Bacon in 1620 hints about the splitting apart of Africa and South America. Francois Place proposed in 1666 that before the ocean flood, the earth must have been undivided. Alexander von Humboldt speculated that the Atlantic was a huge valley scooped out by the sea.
Wegener had evidence to support his theory but could not explain the mechanism behind how the plates move. Jigsaw fit, geological fit, tectonic fit, glacial deposits and fossil evidence supported his theory. In the early 20th century, Alfred Wegener and Frank Taylor independently proposed that the South American-Africa fit was not coincidental and that the plates had moved apart. He suggested that 250 million years ago, the continents had once been massed together in a single supercontinent Pangaea and then gradually drifted apart. When the geology of East and South America and West Africa was mapped, it revealed that ancient rock outcrops, cratons, over 2,000 million years old, were continuous from one continent to the other. Fragments of an old fold mountain belt between 450 and 400 million years ago are found on widely separated continents today. Mountain belts of similar age, rock type, and tectonic history could all be fitted together within a reconstructed supercontinent. Rare identical fossils were found in rocks on different continents now separated by thousands of kilometres of ocean.
Since Wegener's theory was first published, there's been many developments. In 1927, Arthur Holmes elaborated on one of Wegener's many theories, the idea that mantle undergoes thermal convection. This method allowed the continents to move. Not until the 1960s did Holmes' ideas receive any attention, and greater understanding of the ocean floor led to these ideas to be proven to work. These discoveries led geologists Harry Hess and Robert Diaz to publish hypotheses based on mantle convection currents, also known as seafloor spreading. Wegener's work in his lifetime was widely unaccepted, and his arguments did prompt others to conduct research in this area. Wegener's ideas have become the foundations of the theory of plate tectonics, widely accepted today, and is argued to be the most significant scientific theory